start. Okay, I've given you these following exercises as your assignments, okay? And the main reason is I want you to, is it fine if we use a different? Yes, you can use a different method. It's fine, as long as your method is correct. Okay, so I want you to verify this identity in A, and I would want you to verify the identity in B. I've given you a hint for A, which you just use guide 9, and then you see what to do about it. If you don't want to follow that guide, you can use your method as long as your method is right. Okay, I wouldn't have any problem with that. When we get to, okay, now should be a convenient time to go on a break, or should we go at 11? Should we go on a break now or at 11? If no one answers, then I'll continue to 11. Okay, 11, fine. Yes? Okay, so we go on a break at 11. Now we're going to be looking at trigonometric functions of two angles. And there are certain formulas which will be applying for these two angles, to solve these two angles. We'll be applying the addition formulas. There are 4 formulas actually. We'll be applying addition formulas, which is simply sine alpha plus beta. Remember, these are two angles, alpha and beta. Alpha is an angle, beta is another angle. So if you want to take the sine of both angles, angle alpha plus beta, this will be using this formula, sine alpha cos beta plus cos alpha sine beta. The same thing applies to cosine, but for cosine, it's a negative sign, and you'll be multiplying with cos, sine, sine. Tan alpha plus beta, we'll be using this formula for these two angles. For subtraction, we'll be using the subtraction formulas. Then we also have double angle formulas. For instance, what I mean by double angle is sine 2 alpha. 2 alpha implies double angles, and so on. So we have for sine, we have for cosine, we have for tan. And we'll be using these formulas to solve. For half angle, if you have theta over 2, we have the following formulas for sine, for cosine, and for tan, okay? These formulas, if need be, will be given. Otherwise, you need to know them yourself. Let's solve some problems with our formulas. We want to find the values of sine, cosine, and tan of pi over 12. The first thing is, how do we represent pi over 12? Remember, pi over 12, 1, it's not, we cannot use addition formula for it. Pi over 12, as it is, we cannot use subtraction formula for it. Pi over 12, as it is, we cannot use double angle for it. Pi over 12, as it is, we cannot use half angle to solve this. So the first thing then we do is we need to simplify pi over 12. So into multiples, we find the multiples of pi over 12. What are the multiples of pi over 12? We have pi over 3 and pi over 4. Of course, you subtract this from each other. And remember that you can actually represent these as acute angles. Okay, and we already have the tables for our angles. For instance, we have the table for theta, for theta over for 30, theta equals to 0 degrees, for theta equals to 30 degrees, for theta equals to 45, theta equals to 60, 90, etc. So that table now becomes useful here. If you have sine pi over 3 minus pi over 4, of course, I hope you all agree that that will give you pi over 12, right? Do you agree? If you don't agree, you ask. The angle pi over 12 can be represented as pi over 3 minus pi over 4. Okay? And now, since we have represented pi over 12 as pi over 3 minus pi over 4, we can then use the subtraction formula. And what does the subtraction formula say? Sine theta cos theta, sine theta minus sine alpha minus sine beta. Let me write it here so you see. Just write it here. So the subtraction formula says sine y minus I naught plus. You can try using addition and see if you get the same answer. Sine alpha minus beta equals to sine alpha cos beta minus cos alpha sine beta. Okay, so this is the formula we are following. Now we have sine alpha. Alpha is pi over 3 cos beta, which is beta is pi over 4 minus that. And if you go back to your table, now I cannot flip back to that table. Now if you go back to that table, you discover that, okay, let me just do that so that you see. It's way back. But I'll soon get there. This is the table I'm talking about. Okay, you can use this table to solve that problem. So you have pi over 3, 0.87, pi over 4, 0.71, and it's sine of it, right? So you can have pi over 3, 87 minus 0.71. If you use this table, it's fine. Whatever your answer is will be correct. Okay, you can try that at your own time. That's the table I'm just referring to. Or you use your the areas of your triangle. The sides of your triangle. So this is root 3 over 2. That's pi over 3. That's sine pi over 3 is root 3 over 2 times cos pi over 4 is root 2 over 2 minus this, and then you solve, and then you get your final answer. You can express this in the simplest form using your calculator. Your answer will be correct. I'll mark you right. Otherwise, you want to leave it in the short form, you still correct. So I've said that you should attempt B, okay, for pi over 12. You do that at your own time as well, so that you would see that what I'm saying is correct. I just want you to try and attempt to see that it's correct. Then I've done for tan using the same way. Remember the formula for tan for subtraction. If we come back to where's that subtraction? Tan is tan alpha minus tan beta over 1 plus tan alpha tan beta. That's the formula I've used. So you substitute your value of alpha. Let me just write this here. Alpha. This will be alpha. This is alpha. And this is beta, right? So you substitute the value of your alpha and beta, and then you solve, and you have your answer. If you use your calculator to leave it in the simplest form, it's fine by me. But please always show your steps. Okay, this is another exercise for us to do. Express 2, 3 alpha in terms of sine alpha and cos 4 alpha in terms of alpha. Can someone tell me what formula are we going to be using here? For 3 alpha and 4 alpha, what formula are we going to be using? Someone says double angle. What formula are we going to be using? Thanks, Kennel. Can someone else tell me what formula are we going to be using? Addition and double angle. Yes. Kanya, thanks. We'll be using both. We'll be using addition formula and we'll be using double angle. Kennel, you remember double angle will be, let me just write it. Double angle will be 2. It's double, okay? But what we have been given is 3 alpha and 4 alpha. So we cannot directly use our double angle. So the first thing we do is to express 3 alpha and 4 alpha as what? As addition. And that will be 2 alpha plus alpha. This will be what? 2 alpha plus 2 alpha. Okay? So this can also be 2, which can also be 2 times 2 alpha. So it can be both. All right. I just want you to see that. So the first one, which is sine 3 alpha, expressing it in terms of addition, will be sine 2 alpha plus alpha. You can try to check if the answer will be the same. I didn't check that. If you use 4 alpha minus alpha, but it should be because that 4 alpha minus alpha is also the same thing as 3 alpha. It may actually go the long route, okay? Remember in arithmetic, you want to use the shortest route, okay? And sometimes instead of using multiplication, you want to use addition because of the level of complexity they have. Multiplication have more complexity, but maybe the short path. Addition has less complexity, but may go through the long path. Okay, there's always a trade-off, but when you do both, you're going to arrive at the same answer. So in this case now, sine 2, we have represented 3 alpha as 2 alpha plus alpha, okay? And then we now want to use the addition formula to simplify this. We have used the addition formula here, and then you continue. By the time you're done using the formulas, our final answer will be 3 sine alpha minus 4 sine cube alpha. Please try to solve this at your time. And remember, I have given out this lecture notes. since over the weekend. So I would expect you guys to have solved some of the exercises, and that's why I provide the solutions. And if there's any way or any question that you do not understand, it's a good time during the lecture to just point it to say, please, how did you go about it here? Than waiting for me to solve everything during the class. We will not be able to finish our lecture that way. Please, that's why I give out the lecture notes, give the exercises, give the solutions for you to attempt at, and see where you don't understand it. Okay, I'll go to B. B part, I'm just expressing 4 alpha as 2 into 2 alpha. Okay, in this case, I can easily use my double angle formula. Okay, and when I use my double angle formula, my final result becomes 8 cos 4 alpha minus 8 cos square alpha plus 1. All right, you can also try that at your own time. Now, let's look at example number 3. We want to use the half angle formulas to find the exact value of sine 15 degrees. Okay, let me take you back to that formula I'm referring to. This is the formula where you have sine half theta will be equal to plus or minus square root of 1 minus cos theta over 2. And the same thing applies to cos. And then tan is 1 minus cos theta over sine theta. All right. Now we're given sine 15 degrees. So with sine 15 degrees, we have what? Now we're considering sine. Let me go back. You can write this down in your notes. Sine is equal to plus or minus 1 minus cos theta over 2. That's what we want to use there. It's plus or minus 1 minus cos theta over 2. Note here that I have written cos 30 and not cos 15 degrees. Can someone tell me why I've written cos 30 and not 15? Can someone tell me why I've used cos 30 and not 15 degrees? Yes. So it's equivalent to saying sine 30 over 2. It's the same thing as sine 15. That's why I've said equivalent. So to be able to use the half angle formula, remember we need to take the half of this 30, which would be 15. So we put in the double angle. Let me use that word. We put in double angle into where we have theta, and I'll write it here for you. And this is why I'm going through the examples so that you can actually see the way it works. When you have its sine theta equal to plus or minus square root of 1 minus cos theta over 2. So this theta here is the double angle. This let's put it as beta. This beta is 2 theta. Okay, so that's what I've done. That's how it works. So in this case, you continue, you solve, and then you find your answer. You get your answer. You can leave your answer using your calculator in the simplest form, or you want to leave it in the short form. You get your full mark. Okay. Now, I think I'll stop now.